Hello students, and welcome to another video. I'm your teacher, Mr. Flint, and today we're going to be talking about accuracy and precision. Accuracy and precision, okay? Let's define both of these, and I'm going to give some examples, and we'll talk about it. So, accuracy, okay, refers to how close a measurement comes to an accepted value. All right. So I've talked about this in the previous videos, but if you're at the shooting range or you're shooting arrows, it could be a variety of things. When you have an aim, you're trying to hit a specific part of a target. And how accurate you are is how close you are to hitting the exact bullseye of that target. Okay, so for someone who's new to like shooting arrows, for example, you're maybe pretty accurate if you can just hit the board or the haystack or the I don't know, whatever you're shooting at. Okay, but as you get better and better at your skill of shooting arrows, eventually you'll get to the point where hitting the target's easy, but you increase your accuracy and you start to aim for the bullseye or for a certain part of the trajectory that you're trying to hit. Okay. Precision, on the other hand, precision, okay, refers to how close a group, I'm going to wiggle it, a group of measurements comes to each other. Now, this is very important because you may get lucky on your first shot and you may hit the bullseye and you're like, hey, I'm pretty good, right? And you walk away and you show your friends, hey, I got a bullseye on my first try. But your friends ask you, well, can you do it again, right? And the next 5 arrows you miss the target completely. Well, that doesn't, just because you got a good shot once doesn't actually mean you're good at what you're doing, okay? If you're playing basketball and you just happen to hit 2 threes out of 5, you're doing pretty good. But if you only hit 2 out of 100, that's a different scenario there. Okay, there's a balance between accuracy and precision when we're working in the lab. Okay, so what I'm going to do is I'm going to draw some circles. Okay, we're going to kind of model these so we have something to go off of. Okay, so I'm going to do this. I'm going to draw some targets. Okay, I'm going to draw 3. So I'll just draw some targets here. I'm going to draw one more set. Okay, we're going to have a smaller one inside here. So if you need to pause the video, you can. Or if you've kept up with me, then you can keep going. Okay, so I have 3 targets here. And I'm going to draw different groupings. And we're going to just define how accurate and precise it is. So let's say you're an excellent marksman and you've been doing this a long time and your arrows all hit the middle of the targets. Let's say there's 5 of them and they're all at the center of the bullseye, right where you were wanting to aim. We would describe this as accurate and precise. I'm going to do A and P. Okay, that's just short. I don't have to write it out. Okay. Now, what if I'm at the range and I'm shooting, like, just say a rifle, and I'm getting it tuned in for the hunt in the season, and I do my first round of shooting, and I find that all of my bullets are hitting this end of the target. Okay, yeah, there's a very tight grouping here, which means there's some high precision. Okay, you have a good grouping, but is it hitting the target? It's not. So it's not accurate. So I would say, we'll use this pen. Not accurate, but it is precise. But precise. Okay, so it is precise, but it's not accurate. Okay? All right. Now, what if you do this? You hit a bullseye, and then you spread out your data points here. Okay? But if you take the locations of these and you kind of center them, kind of like we centered here, it looks like you're honing in on the accuracy. Okay, this is showing that it is accurate, because if you average out kind of the spacing of these, you actually kind of end up in the center. So this is accurate, but is it very precise? No, the groupings are really spread out. So it's not precise. It has terrible grouping, but our data comes out correct. So that's what happens sometimes when we're doing science experiments, where our data doesn't look good, but our numbers look good. Like our averages look good, right? So when we're doing experiments, you have to take account for both, because just because your numbers fall in a range doesn't mean it's actually in that range. You could have numbers that are all over the place, that are really scattered, but when you average them out, it happens to be where you need to be. Okay, and if it doesn't have any of these characteristics, it's neither accurate nor precise. Okay, so if it's scattered around, terrible grouping, and it's not hitting where you're wanting to hit, then that's going to be neither accurate nor precise. Okay, there'll be problems like this on your test, and there'll be some practice problems to work on, so you can hone in on these examples. But if you understand these models, you're going to be in a pretty good place. Okay, thanks again for watching. Until next time.